They're out there, alone, drifting through the deep space like cosmic ghosts. No light, no warmth, no sun to call home. These are rogue planets, solitary worlds that float freely through the universe, as if they were cast out from their original star systems. Or maybe they never had one to begin with. And the most mind-blowing part? There could be billions of them. Yes, billions. Some estimates suggest there may be more rogue planets in our galaxy than stars. That changes everything. But how is that even possible? Most planets are born inside a solar system orbiting a star. But in some cases, the gravitational dance between celestial bodies becomes unstable. A planet might be flung out by a collision or pushed away by a massive gas giant, like a cosmic game of billiards. The result? Ejected, doomed to wander the cold darkness of space forever. Imagine a world like Jupiter, but floating alone, receiving no sunlight, covered in eternal storms under a sky that never sees day. Some of these planets are huge, with dense atmospheres, violent winds, and maybe even underground oceans warmed by internal heat. A bizarre environment, but maybe not completely lifeless. The creepiest part? They're almost invisible. Without a star to illuminate them, they hide in the dark. We can only detect them using advanced methods like gravitational microlensing, when the gravity of the rogue planet bends the light from a distant star as it passes in front. A phenomenon so subtle, it's like trying to hear a whisper in the middle of a thunderstorm. And that raises the ultimate question. What else might be drifting out there, hidden in the shadows of the cosmos? Picture an entire planet, drifting alone through space. No star, no day, no night. Just an endless ocean of darkness in every direction. These are rogue planets, also called orphan planets or interstellar wanderers. And the most disturbing part? They're not rare. Some studies suggest that there are more rogue planets in the galaxy than there are stars. Yes, you heard that right. Instead of trillions of stars with their planets, we're talking about quintillions of silent wandering worlds. But where do they come from? How does a planet lose its star? The answer lies in the chaotic birth of planetary systems. In the first million years of a solar system's life, the gravitational dance between giant planets is brutal. Some grow too large, others migrate too close to the star, and in that struggle, many are flung away, ejected, abandoned, exiled forever into the dark. But here comes the first big surprise. They can still be warm. Even without a sun, many rogue planets, especially gas giants, retain internal heat for billions of years, thanks to leftover energy from their formation and internal friction. Some may have active volcanoes, shifting geological layers, and most importantly, subsurface oceans. Sound familiar? That's exactly what we see in moons like Europa and Enceladus, frozen on the outside but hiding warm oceans beneath. Oceans that may host life. And this leads to the big question. Can rogue planets support life? The answer, yes. Maybe even intelligent life. Most life on Earth doesn't directly rely on sunlight. In the deep ocean, thousands of meters below the surface, life thrives around hydrothermal vents, fueled by geothermal energy. If it's possible, here, why not there? Now imagine a planet covered in ice. No atmosphere, no visible signs of life. But underneath the icy crust, a vast, liquid ocean, dark, warm, rich in minerals, perhaps inhabited by organisms that never evolved eyes, creatures that sense heat, pressure, or magnetic fields instead of light. And if those organisms had billions of years to evolve, could they develop intelligence, culture, technology, without ever seeing a star? It's terrifying to think, and even more terrifying to realize, we would never know. Such planets are completely invisible to our telescopes. No reflected light, no infrared signature from a star, just floating ghosts in the void, which leads us to a bold idea. What if an advanced alien civilization used a rogue planet as a hideout? Think about it. A rogue world is the perfect stealth base. Undetectable, mobile, silent. A hidden mothership disguised as a planet. This theory has even been discussed by some SETI researchers, who argue that if intelligent life exists and wants to remain hidden, a rogue planet is the ultimate cover. And now imagine something even scarier. A rogue planet passing through our solar system. That's not just sci-fi. Some anomalies in the outer solar system, like Sedna's orbit, suggest the past influence of a massive, unseen object. If a rogue planet crossed paths with our neighborhood, the damage could be catastrophic. Orbital shifts, tidal chaos, Earth ejected from its orbit, civilization gone in days. But here's the wildest theory of all. What if life on Earth came from a rogue planet? That's the idea behind interstellar panspermia, the theory that microbial life can travel across space, hidden inside asteroids, comets, or planetary debris. Maybe, billions of years ago, a rogue planet passed near the early true solar system, and fragments of its crust, rich with microscopic life, landed on Earth. If true, we are the aliens, children of a forgotten world, descendants of a traveler lost in the void. It sounds insane, but science already confirms that rogue planets exist by the billions, that they can be warm, that they can hold liquid water, and that some might be closer than we think. They are the dark side of the galaxy, the cosmic nomads, bearers of secrets older than Earth itself. And while we sleep peacefully under the sun, these frozen giants continue their silent journey through the abyss, watching perhaps, or waiting to be found. Now imagine this. A rogue planet, 10 times the size of Jupiter, begins drifting silently toward our solar system. It's not coming fast. These objects move slowly, over thousands or even millions of years. But the moment it crosses into the Oort cloud, our system's icy outer shell, the countdown begins. At first, telescopes on Earth would detect a subtle gravitational wobble in distant comets, as if something massive were tugging at them. Astronomers would notice clusters of long-period comets behaving strangely, falling toward the inner solar system in unusual patterns. Then comes the shock. A dark object, invisible in regular light, but glowing faintly in infrared. A planet, with no star, a nomad. Its trajectory would become the most analyzed path in human history. If it's just passing by, far beyond Neptune, there may only be slight disturbances. But if it cuts deeper, chaos could unfold. Even if it never touches a planet, its gravity could pull Earth slightly out of its stable orbit, lengthening our years, disrupting seasons, triggering climate collapse. Jupiter's moons could be ripped away, Saturn's rings disrupted, Neptune's outer satellites ejected into deep space, the orbits of thousands of asteroids and comets completely rewritten. And Earth could face tides more extreme than anything we've ever known. Oceans flooding coastlines, the moon's orbit shifting, geological instability. Mass extinctions wouldn't even require a direct hit. And here's the terrifying part. Rogue planets don't even have to come close to destroy us. Their gravitational influence alone is enough to unravel the harmony we've lived in for billions of years. But let's go darker. What if this rogue planet isn't just a cold gas giant? What if it's something more exotic, like a failed star, a brown dwarf still radiating faint heat and X-rays with a dense magnetic field? As it passes through the heliosphere, the magnetic shield of our sun, it could compress it, exposing Earth to cosmic radiation, frying satellites, disrupting global communications, even shutting down power grids. Worse yet, some scientists speculate that a rogue planet could carry life, ancient microbial hitchhikers frozen in its crust or trapped beneath an icy ocean. If fragments of it collided with Earth, that's panspermia in action, life seeded by chaos. Now remember, the night sky we love so much, isn't static. It's a battlefield of gravitational forces, constantly shifting, rebalancing. A rogue planet entering our system isn't just science fiction. It's a ticking time bomb that could already be on its way. When we think of rogue planets, the first image that comes to mind is a giant drifting through space, wandering aimlessly, far from any star. But what happens when these rogue planets pass through a solar system like ours? Their immense gravity, can have catastrophic effects, altering the orbits of planets, asteroids, and even comets. In extreme cases, they can even change the fate of entire solar systems, creating a kind of gravitational chaos. But these planets aren't easy to see. So how do we detect them? And more importantly, how do we even know they exist? Because of their size and gravitational strength, rogue planets can dramatically reshape the structure of a solar system. When one of these planets enters a star system, its massive gravity can disrupt the orbits of planets and other celestial bodies. Imagine a giant like Jupiter, or larger, approaching a system like ours. Its pull could push planets into unstable orbits or even eject them completely. If a rogue planet came near Earth, it could shift our orbit, moving us closer or farther from the sun, changing our seasons, climate, and even habitability. This gravitational disturbance might also dislodge asteroids or comets, flinging them inward or outward, creating a cosmic domino effect. While rare, these events are a reminder of how chaotic space can become when a rogue planet crashes through, leaving a trail of destruction. Now comes the question that fascinates everyone. How do we detect planets that don't emit or reflect light? The answer lies in two revolutionary methods. The first is gravitational microlensing. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light, briefly making it brighter. This rare effect allows astronomers to see the presence of a planet that's otherwise invisible. The second method uses telescopes that detect infrared radiation. Even cold, dark rogue planets emit a tiny bit of heat. Space telescopes like James Webb or WISE are designed to capture that faint glow. To these telescopes, rogue planets show up as small, warm blips in the cold dark of space, almost like thermal shadows moving across a frozen void. Among the rogue planets we've found, one stands out: CFBDSIR 21490403, discovered in 2012, located about 100 light-years from Earth. This planet is a true giant, with a mass between 4 and 7 times that of Jupiter. It doesn't orbit any star. Instead, it floats freely through space, cold and nearly invisible. Its discovery shocked scientists because such a massive planet wasn't expected to exist without a star. CFBDSIR 21490403 likely formed in a young solar system and was violently ejected before it could settle into a stable orbit. Its existence forced astronomers to rethink how rogue planets are born. Could many others be drifting out there unnoticed? If so, what effect do they have on the galaxy? The more we discover, the more it becomes clear that these lonely giants aren't rare. They're just hiding in the dark, shaping the universe in ways we're only beginning to understand. Want to dive deeper into the mysteries of rogue planets and the dark side of the cosmos? Subscribe now and join the journey through the unseen universe.